everyone. Thanks for coming to my talk, Mission Impossible Dead Reckoning Pain. Today, I'm going to be telling you a story about a real life project that I had to do that had become the inspiration for this talk. So just normally when I'm in Australia, I do a quick acknowledgement of country, mainly because, you know, us as settlers, we went in and basically stole their country. So I'll just do a improvised version for Korea. I want to acknowledge the Korean people of the Korean nation, and I'm here to drink lots of beer and soju. So please join me in indulging after this presentation. So just a introduction about myself. My name is Francis Chung. I actually run two meetup groups, the Alt.net and DDD-AU meetups in Sydney, in Australia. I've been in the industry for about 30 years. Fun fact, my first computer was an 8-bit computer called the Apple II, which you may have heard of. Now, the question is, am I a real Apple fanboy? As I'm doing this presentation on a fake Apple laptop. So you be the judge of that. So if you've been in the industry as long as I have, for around 30 years, all your stories kind of start with once upon a time. So, once upon a time, I worked as a principal engineer at FreshBooks in a city far, far away called Amsterdam, or maybe some of you know it as Amsterdamage if I indulge in the local coffee there. So, FreshBooks is a accounting platform whose main market was in the US and Canada, and it has about 1 million plus users worldwide. And I mean 1 million paying customers worldwide. So, sticking to the theme, a impossible mission was given to myself, um, and I had to basically introduce a new user class called a firm accountant. And you might be wondering, how is this an impossible mission? And what in the world is a firm accountant? Is it this handsome accountant with a firm rifle grip and that firm stare? No, it's not. It's a good movie, by the way, so I recommend everyone having a look at it if you get a chance. It's kind of more like this guy with the firm accountant looks. Yeah, I know the world can be cruel sometimes. So basically, a firm accountant needs like a external accountant, an auditor that needs like a lot of your normal accountant's access rights, but perhaps not everything that the uh, accountant has. So just want to apologize to any real accountants in the room. So I'll actually take a crow beating in the corner after the Q&A session at the end. So please ask a million gazillion questions during Q&A. So yeah, the firm accountant being basically an external auditor and external accountant. I mean, adding this user, how hard can it possibly be, right? So I basically started doing some analysis, and basically I had 933 potential code changes, basically spanning across the entire six systems. That's not a small number of changes. And I was given just one intern developer for the project. I wasn't allowed to code. They said it was too expensive, but I don't know whether it was too expensive for me to actually be doing coding or the actual bugs I would be generating. And I just had 2 months to deliver this. So the code changes were not the biggest challenge. It was basically the first new user class that they had introduced in over 5 years. Testing this, however, basically required end-to-end testing of the entire system, which is a daunting thing to do, right? And it also didn't help that I was unfamiliar with most of FreshBooks' ecosystem. So you can imagine, the what was going through my head at the time when I was doing this analysis and also finding out what my constraints were. So, and hence, I guess, that became the inspiration for the title of my talk today. So you might be wondering what happened. So, let's just fast forward to about 2.5 months later, roughly speaking. And then, like most IT projects, this one was late as well. So basically, what I did was just booking a lot of Zoom meetings and just me begging for more resources. So I did convince one or two teams to, perhaps take responsibility for the changes that was in their domain, but I still had to do the majority of the changes, and I also convinced people that I should actually be helping the intern develop out and not, maybe we shouldn't settle everything onto the full shoulders of the intern developer. And I actually delivered the project, so it was a little bit late, but like I think considering the circumstances, I think I did pretty well. And also, I didn't break production like some of the Las Vegas bookies were predicting. So don't bet against France, okay? So finally, when I got a chance to lie down and reflect upon what I did, I realized what I really should have done was jump out of the building and run for my life, maybe go back towards Australia. Like it was a bit of an insane project. The stress was pretty intense, not just for myself, but for the poor intern. And being a principal engineer, you could kind of, you have a good idea of what's on the roadmap, and I could definitely see, they're going to need to add more user classes for some of the features that they wanted to bring on board. So, hey Francis, we need a new user class called the soft accountant, and guess who's going to be doing this project again? It's going to be me and my poor intern, right? So I think the fear and the PTSD got me pretty proactive into trying to see if there was a better way of doing this, and what I discovered will form the basis of the next part of my talk. So that's the end of part one. Uh, in part two, we'll take a deeper dive, and I'll just quickly go over the agenda. So if you haven't guessed from the title of my talk, or what I've kind of spoke about so far, it's about permissions. I want to do a quick intro uh, about authentications versus authorization, because this is something that people kind of get confused sometimes. I'll talk talk to you about different access control models. I'll go through some code examples for a particular solution I'm going to kind of showcase. We'll have a really, 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 really long Q&A session, and maybe we might just have time for a quick meeting at the end. So when you talk about application security and permissions, I think what people are really talking about is authentication and authorization, which kind of both hand in hand, but then not quite the same. So, what is authentication and what is authorization? So, authentication is basically, are you who you say you really are? So that it is. That's it in a nutshell. And so imagine having someone like Ethan Hunt as a user. He'd be pretty nightmare to authenticate, don't you think? And authorization is basically as user X, what are you allowed to do? But the more important part is what aren't you allowed to do? And this is where normally that second part is normally where if you don't get it right, you can get into all sorts of problems. And today I'm mainly going to be talking about authorization. So before we kind of start getting deeper, I wanted to quickly paint you a picture of how authorization worked at FreshBooks. So um, this is like a C4 diagram of all the systems in FreshBooks. Yeah, apologies if it looks a little bit blurry. That's the only copy that I have. And like I think we don't actually want to go into the details of anything on this diagram. I think the main thing, you need to kind of uh, get kind of realize is that all the systems and all the systems kind of on around on the outside, everything is pointing to the system that's in the middle. And basically, that system in the middle was FreshBooks' core authentication and authorization system called MasterLock. Now, remember earlier that I said I had to change 933 things across six systems? Well, these were the six systems, just as an FYI. So, so as I was saying before, everything kind of depends on MasterLock. So So let's have a look at, okay, I had to potentially change 933 places to introduce this new user class. So let's have a look at what one of them might look like. And before we go on, I also want to have a quick chat about the tech stack at FreshBooks. You know, since we're all engineers, we're all voyeurs when it comes to other people's tech stack. So let me let you indulge you in a little bit of what FreshBooks look like. So they basically had a JavaScript stack that basically had React and the Express.js backend for the UI part. And I think just for all the backend systems, it was mainly written in Python. Masterlock, which is the authentication and authorization system, however, was written in Ruby on Rails. Interesting choice. So they basically picked basically two open source libraries called Device and Pundit for the authentication and authorization part. Is anyone here Ruby on Rails developers here? Okay, so and I think for authorization calls, they kind of expect 50 milliseconds. It's supposed to be like kind of like the industry standard for what they expect. Um, but we had a problem at FreshBooks. Our Masterlock's calls were kind of getting slower and slower. So basically, our data log threshold, the APM that FreshBooks used, we had to increase basically the budget or the threshold from 250 milliseconds to 600 milliseconds. And what that means is, some authorization calls were taking up to 600 milliseconds, which is 12 times what the standard industry standard of 50 milliseconds, right? So so this kind of increased and slower authorization calls were impacting our UX negatively, and they're kind of coming back from kind of some of the customer feedback we were getting. And it was a bit of a decentralized mess. So basically, you had all the uh, like a role data, your user role data was sitting on one part of the system, and then all the logic was kind of distributed across basically with the application layer. So that means it was all over the place, basically. So now let's have a look at what a typical code for like checking permissions kind of look like. So this is like one of the 933 places I needed to check. So it's like a bog standard kind of like API endpoint call. So I think in this particular example, we're trying to update something or we're trying to put something from a client end. So simply, what we're doing is whether we have actually the permission to, to update something, and we kind of raise an error if we can't. So, pretty simple stuff. And on the basically, it was typically our business objects that had also this kind of like permission kind of check um, logic. And what typically how it was structured was basically you'll have all these operations here, so you can see like can read or can update, and basically it was just a simple check to see if the user had any belonged in any particular roles that was allowed to perform a particular action. So, going back to my example, so if you wanted to update something in for this particular business object, you basically had to be either in the business partner role, the business owner role, or the accountant partner role. So, I mean, okay, I just showed you some code, but let me kind of show you like a call graph just to give you uh, a visual kind of flow of what actually happens. So if an application is trying to do something, so let's say it's trying to update something here, it's going to make an authorization call to master log, and but before we do anything, we've got to make sure that this person is who this, who he says he is. So especially if the user is Ethan Hunt. So we do kind of like an authentication check first. And once we're happy with that, what we do is we go to the authorization part of a master log. And what we're getting is we're trying to get all the membership information, or, you know, kind of like kind of all the different roles that this particular user belongs to. And that gets sent back to the application. So now the application has all the kind of roles that this user belongs to. Now it's going to do, the role membership check, as you recall, all sits with the application, and that happens in the application layer, and then it will make a decision about whether this particular action should be authorized or not. And also remember that this whole going back and forth was taking up to 600 milliseconds. So you've probably seen like this type of code yourself before, and you may have even worked on code like this, I believe. So it's called role-based security, and then it uses something called role-based access control. So it's basically like just using kind of like a membership check of a user of particular roles to see whether something should happen or not. So, what are the pros and cons with role-based access control or RBAC? So, it's pretty ubiquitous. Everyone's probably seen it and done it before. It's fairly easy to implement. You're just doing a membership check here. It's great for small to medium apps, and it's also great if you've got a well-defined permission set that doesn't change. What are the cons? So, as you've seen, it's not scalable for enterprise or SaaS apps sometimes. You have something called role explosion, where basically you're just inventing roles just for the sake of satisfying some edge case authorization or scenarios. So maybe you guys have, maybe joined a new company, and you're having a look at like what sort of permissions they have in the application you're not unfamiliar with, and you might see something like they have like 5,000 roles, all sorts of different types of permissions, and you have no idea what any of the 5,000 roles actually even do. So, um, so some of the cons also, it's you might have seen it. You can only really do very simple low granular permissions. And if you try to do something more complicated, this is where role explosion happens. And sometimes there's also, there's a tight coupling between the permission logic and the code logic as well. So, are there any alternatives out there? And I just had to fill my cat meme quota here. So that's checked. Uh, so I came across something called attribute-based access control, or ABAC. And what ABAC is in a nutshell is it's basically doing authorization checks, but you're using attributes from 4 different areas, and plus also you're incorporating something called policies as well. And those four different areas are like user. So in any kind of like permission scenario, there's always the central figure is going to be the user. And the other thing that a user would want to do is, it's going to be wanting to interact with the resource, right? So basically a resource and an action, and the authorization scenario that normally also happens in an environment. So whether it's live or production or dev or whatever, so there's also normally an environment involved. So this is like a good visual representation of what ABAC looks like. So we have an ABAC authorization engine in the middle. It will just, consider all these different attributes you've kind of defined. So perhaps for this particular authorization scenario, maybe a paid is an important attribute, you know, and things like what, whatever the action is, and you could consider things like rate limit as well. And what you can do is also find something called policies, where that's kind of like a more general kind of blanket type thing, where you can maybe permit certain actions under certain conditions, or deny certain actions under certain conditions as well. So ABAC look kind of promising, and you might have seen something ABAC uh, in basically. If you use the cloud, so like cloud providers kind of provide an ABAC to let you protect your cloud resources and your cloud infrastructure on their platform. So what's ABAC? What are the pros? And I'm going to give you a hint here. A lot of the cons from RBAC are going to be the pros in ABAC. So it's it lets you do granular flexible permissions. It's scalable if you do it right. It offers much better security and compliance. It's obviously centralized, like cloud providers provide this if you want to use it. So what are the cons? So as you can see, like role based was pretty simple. It was just about membership of a particular role. But this thing's now you've got like you've got policies, and you've got like all these different attributes that can influence whether something is authorized or not. So it's become a lot more complex. There's also potential issue with performance and latency if you don't do it correctly. Um, it's because it's complex. It's going to be much harder to audit. And ABAC, I think, has a standard called XACML, which is kind of like de facto language that's used to define ABAC. And it's again, the con is also, the cloud providers seem to be the only one that are providing this to just use exclusively just with their cloud resources only, and then not on your application. So, and I mentioned XACML before. So this is like an example of a sample policy defined in XACML, and I'm just not even going to I've worked with XML for a while, but I'm not even going to attempt to decipher what this actual policy is. It's as you can see, it's pretty horrible, right? And yeah, any XML fans or devotees out there? No? Yes? Um, so I thought I'd show you an uh, amusing anecdote about XML with you guys. Came across this quote, this mad American US engineer called Chris Maidens, said, XML is like violence. If it doesn't solve your problem, you're not using enough of it. I'm pretty sure this guy, Chris, would have voted for Trump, if he was still alive. So I quickly realized, after seeing XACML, that this is not the way. And then I came across something called Google Zanzibar. And you might be thinking, is it the famous salad bar in the famous staff restaurants? No, it isn't. But I just want you guys to take a look at this impressive salad bar that they have on display. You know, definitely enough to make me go vegan at least one meal per week. So Google's Zanzibar is basically Google's authentication and authorization system, but this is all for all of Google's services. It's basically their master log, if you like. And it covers all their products. So like imagine Google Calendar, Google Cloud, Google Drive, Google Maps, Photos, YouTube, etc., etc. And it was first announced as a white paper in 2019. So um, it's a really impressive stats here. They claim to have a 95% latency of less than 10 milliseconds. Remember, the industry standard was 50, and these guys are doing 5 times more quicker. Uh, they have a availability of 5 nines over 3 years, which is also very, very impressive as well. Um, and what Google Zanzibar has is it's basically modeling all those permissions with basically they've got about 2 trillion relational tuples that basically occupy close to 100 terabytes for all their systems. And they claim to be handling over 10 million client queries per second with all the with the above reliability that I just mentioned. And they do this with only like 10,000 servers basically organized in different clusters. So, these are truly impressive kind of not only just performance stats, but these are like planet scale numbers, right? So now when someone says the word planet scale, you need to be very, 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 very suspicious and very wary because your needs are on that far left, that little tiny speck. And normally big tech like Google and, you know, uh, Microsoft and so on, they basically planet scale needs. So, just you guys, need to be wary of this. And, we've all read this classic O'Reilly, classic book, right? This classic text. Okay. I want to see raise of hands, who's been burnt by Kubernetes and microservices. Okay, so let's take a deeper dive at Google Zanzibar. So earlier I mentioned the 2 trillion relational tuples. So that was going to be a hint of what Zanzibar uses underneath, and they use something called relationship-based access control. So a tuple is just a data structure with 3 things in it. So I think in a authorization scenario, I think the 2 important things are going to be the user and the resource, and also what sort of action, or in this case, relation that's going to be uh, exists between the object and the 2 important things, which is the object and the user. So imagine you've got all these bunch of tuples all over the place, and what's great about tuples is you can build a hierarchical kind of uh, uh, data access structure, something like a tree or graph, to kind of build out your access control model. So in this particular example, I'm kind of showing you maybe a user called Bob. Maybe this is like his Google Drive, what's on his Google Drive. And this is like, imagine if I've got all these relational tuples that, when we kind of form them together, actually form a nice kind of tree, uh, which also kind of shows you what the relationship is between the files, folders, and the user. So maybe we can take a step back now and kind of look at it from more of a conceptual viewpoint and what each different access control model can kind of offer. So if RBAC can do a certain amount of things, then you can probably do everything that RBAC does, uh, and more with Reback, and also the same now goes, same also applies with ABAC as well. I know despite what this diagram says, I'm actually the more uh, times I kind of give this presentation, I'm more convinced that, everything you can do in ABAC, you should be able to do in Redac as well. So it's just, yeah, that's something you guys should just be aware of. So, what are the pros and cons of Reback? I'm going to give you a hint now. It's going to be pretty similar with ABAC. So, it lets you do granular and flexible permissions. It's scalable. As you've seen before, it can be quite visual and graphical, and it's centralized like ABAC. Also, the cons are going to be fairly similar as well. So, like relationships can be quite complex to map. So, and it's going to be a learning curve involved, so especially if you're not familiar with things like graph theory. Um, I've read somewhere that it's not granular as ABAC, but I'm kind of disagreeing on my own presentation slides. Perhaps that's true, perhaps it's not, but I've not done enough of two to kind of really have a solid opinion on this. Again, anything that's complex is going to be difficult to audit at times. And this is a bit of a kicker. So none of the cloud providers were not even offering Reback, even just to manage their own resources. So no one's actually offering this. But, fear not. I mentioned that this was announced as a white paper in 2019, and it made such an impact in certain certainly in the permissions authorization kind of community space that a whole bunch of people kind of rushed out to build their own solution. And as you can see, there's quite a few open source and even some commercial solutions that have come out and available in the market right now. So today I'm just going to maybe perhaps showcase Topaz and then showcase how Reback looks like in Topaz. And I picked Topaz for several reasons. It's an open source. What is Topaz? So Topaz is a open source project by a company called Acerto. It supports Zanzibar, but it also supports something called the Open Policy Agent. And what Open Policy Agent is, it's this Cloud Native Computing Foundation, or CNCF project, that basically lets you declaratively write, policies. Remember policies from the ABAC model. But it lets you write policies as code, basically. So imagine, yeah. So basically, it's kind of like Terraform, if you like, but it's for policies. Um, and what these policies look like, they kind of look like JSON, and not violent XML. So, and Topaz also supports RBAC, ABAC, and Reback all under the hood, which is not many of its competitors do. But just quickly, let's go to what Topaz looks like. So Topaz is an authorization engine, which means, okay, you still have to handle your authentication outside of Topaz, which is why, like, you can see the identity providers on the top left of the diagram. And I mentioned everything in Topaz is driven by everything's a policy, right? It's policies that drive everything in Topaz. And I mentioned you can write that as code, so that means, like, you can store them in GitLab or GitHub or whatever your favorite code repository is. And once any decisions that Topaz makes, everything gets logged and it gets streamed out or published out to SIEM tools. So what SIEM is, basically security information and event management tools. So basically they're just just think of them as dashboards that security, like, you can use to just see how your uh, Topaz and other parts of your system are behaving from a authorization viewpoint. So I mentioned that Topaz policies are like JSON-like structures and not violent XML. So let's quickly go through it. So one of the things that kind of struck out to me is how simple and elegant it is. So in this particular example, um, this basically policy is to check whether this user belongs to the viewer role, the viewer role or the viewer group, and if so, it's going to give access to this particular tenant's resources. Right. So I mentioned it also supports reback. So in this particular example, you know, we're checking to see whether this user has this relations between this document called, can I read this particular document? And if that user has that relation, then we're going to allow that user to be able to read this document. So I want to do just a quick side-by-side comparison between the RBAC example and the readback example that I just described. And you can kind of see the data structure is exactly the same. And it's just in the relation field, you can kind of specify either a role or group, or you can specify a actual relation. And it's kind of like you can kind of see, or you can do both. So if you can see the power of something like Topaz, where it kind of lets you mix and match between the two different access control models, which is I think it's very, very, very powerful and profound. So I also mentioned that it supports ABAC. So one of the things like is okay. There's a policy now here. It's a little bit different. So it's using things like time and like your role membership and so on. So this ABAC policy example it's basically checking to see whether this particular user is in the sales team and whether the time of access is during working hours, basically. So yeah, so you can have policies like that. That kind of maybe if you want to impose certain types of like organizational policies, that you can see how elegant and simple it is to do so. So Um, yeah, there's a lot of different like Topaz supports, pretty much all the major languages. I kind of picked ASP.NET Core mainly because it was the only example that I could fit in one slide. But I think that also kind of demonstrate how powerful and like how many features you get out of the box with like an enterprise solution like ASP.NET Core. So if you wanted to have Topaz on your system and let's say you ASP.NET Core is what you run, then you only need basically 4 lines of code basically in the startup.cs, and you just need one attribute for every API endpoint that you want to use Topaz on. And that's it. That's how simple it is. So I'll just quickly go through the startup.cs. The first 2 lines is basically, asking ASP.NET Core to, hey, can you use these the sort of libraries? And also there's also reference to the policies as well. And the next line is saying, hey, ASP.NET, you know, can you add this authorization engine to your one of the middleware kind of libraries? And the last line is basically just asking ASP.NET Core where to go to for the policies. And yeah, for every endpoint, all you have to do is you're adding basically an attribute which kind of says, hey endpoint, when you want to do an authorization check for this particular endpoint, can you actually use the Asserto authorization engine or Topaz, right? So that's it. And these having these 4 lines of code and attributes across your system means you have access to ABAC, RBAC, and RBAC. So, so which path should I be taking? Well, if I'm for my next system, I would actually say, look, I think it's okay to start with something like role-based access security, but if your needs changes and you have to consider other access control models as well, I think hopefully what I've shown you is, there are solutions out there that will make this kind of transition seamless, and then you can consider other access control models if you need to. So just quickly wanted to go back to my FreshBooks example where, my dream, well, my vision was to replace Masterlock with something like Topaz, and I would use something like the Strangler Fig pattern or an API gateway to, gradually kind of basically phase out Masterlock and then phase in Topaz. So just quickly, there were other access control models that I came across, but they're kind of out of scope. And I think, a lot of these are kind of like maybe had more specific use cases rather than general use cases. But I just thought I'll just list it out here in case anyone's interested. Um, and just want to do some quick acknowledgements. So Ben Robinson, our kind of Portington, is now a full stack developer working at a rival company called Rapbook. Chris Simon, who actually is the founder of one of the uh, um, meetup groups that I help run. He served as a mentor to me for this conference called Programmable, where I first debuted this talk. And just lastly, a quick shout out to George, who sat through many iterations of this particular presentation you're seeing. So just a quick takeaway, if there's only one thing is, look, if you get stuck in a solution and you think, is there any way out of this permission hell? There are solutions out there, so there's no need to jump out of buildings. So yeah, this is the Q&A part of the talk where you're going to be asking a million questions, right? And, since there are no accountants in the room, I thought I'll just show you what a simulated accrual beating looks like. And these are the references for that I used for my presentation. So if anyone's interested, yeah. You can also send me a LinkedIn request on LinkedIn, and I'm happy to provide you via mail or whatever communications medium you prefer. And yeah, that's the end of my slides. So I want to thank everyone for coming today, and I hope you have a great evening.